Okay, so hello and welcome to the last Brno Java user group that we had before summer. Today, because we like better presenters, you will need to listen to me. Help yourself to food as usually, and let's talk a little bit about Quarkus versus Spring. So for those of you who don't know me, my name is Martin Štefanko. I work now in IBM directly on Quarkus. So of course this talk will be biased, but I will try to stay as relevant as possible. I lead this user group. I am also micropropal committer, and last year I released my first and so far the only book, Quarkus in Action, and you can find me everywhere online as xstefan. So, what I want to talk about today is basically where we stand in 2026 with regards to Quarkus and Spring Boot. I suppose that most of you, if not all, are Spring Boot developers, so we would like to see where we stand. I will go through some basic stats, then I want to show you dev mode if you haven't seen it before, because that's one of the main convention points that's basically, at least for engineers, is the top priority. I will talk a little bit of performance, where we are making quite nice discoveries lately, and I will finish with like some putting it all together. Please shout questions as we are going, because I don't really want to have this like a presentation for 1 hour and then we will talk. We can like continue walking even after 1 hour, so please shout at me. This should be more like a discussion. So, stats. Quarkus was 7 years old in March, by the end of March. So what we achieved in 7 years. So far, still the main repository which you will find when you are searching for Quarkus is quarkus.io/Quarkus. Everything that Quarkus does is on GitHub. Everything is open source. I will talk a little bit about products, but probably hopefully after the talk. This is not the point of like this talk. So what we did in 7 years is 15.7K of stars, 3.2K of forks, almost 500 releases. This is actually already outdated because there was a release yesterday, as always, before my talk. So the latest is now 337, but like for our purposes, it doesn't really matter. What Quarkus is doing, and where I think that it really shines, is that minors are released once per month. Micro releases are released weekly. Every minor release is always branched from main, basically always taking the state of the main as it is, so the latest greatest. Micro releases then usually come after that on a split branch for the minor release, usually up to 3, so usually 1, 2, but sometimes 3 if we manage. And depending, of course, on the CVEs, which are lately slight problem with some of the AI models. So basically, these are like guaranteeing backwards compatibility for sure. Minors usually are backwards compatible, but not always. So that's already something that you need to think of. But I will show you in the talk like some magic that we can do that you don't really care about. Everything that we do and what we plan to do is again available on GitHub. So you have this wiki page where you can see actual dates for everything that is going to be released. I think that we are already going to Quarkus Port 2, so it will be there very shortly. Then I want to really quickly talk about something which we have, and again, this is only community. So in community, we also do long-term support, LTS releases, which is basically a minor which is supported for 1 year for people that don't want to really move as fast as Quarkus is able to go, because yes, things break, things change, and a lot of features are added. It's not like the most stable thing in the world because we want to move fast. So if you prefer to stay on something stable, you have these LTS branches, which are released every 6 months. So we will take one minor every 6 months, and we will support that minor not only for that 1, 2, 3 minor releases. We are going to continue doing these minor releases for up to 1 year, which are basically released every 2 months. Yeah, so if you prioritize stability, then this is for you. What is basically happening is that if like the LTS release would be 3.20.x, then we will actually branch this from 3.19, so even the features which are in 3.20 are not inside that LTS stream, and that's just because we want to really make it as stable as possible. Then if you choose this, then basically you are, like, you can be sure that you are basically only limited to, or what you will get in the microseries are bug fixes, CVE fixes, of course, but only moderate and critical, because otherwise it would be not very sustainable. And of course dependency updates if the CVE requires it. But nothing else. So if you want to stay on something stable, this is actually pretty good case. And this is, again, guaranteed for community, so this is really not something that people need to pay for. If you want to check until when which stream is supported, again, everything is on quarkus.io, so you can find this page where you can basically see which releases are LTS and for how long they are going to be supported. And of course, if you are working for a company that is interested in support, then you see that basically which of them have actually RHBQ, Red Hat build of Quarkus, so Red Hat supported version of Quarkus, or IBM, basically the same thing but from IBM. I don't really know what that hero devs is, so I will not comment on it, but on the last column you see the latest releases, and you see that sometimes we need to even go into that fourth number, which I don't know if it has a name, so mini micro. Because sometimes we are actually required to do out-of-bound releases for very critical CVEs, which are happening more than often lately. So you see a lot of 4-digit stuff, but the original plan is what I presented on the last slide. And you can of course verify all of this on GitHub, so you see that this is going like pretty fast. 7 weeks, 7 days, 2 weeks, 3 weeks, 5 weeks. So we are going pretty fast. What I am particularly proud of that in these 7 years we already passed 1,200 contributors just in the main repository, which I think is awesome. And we have a lot of really awesome people doing this awesome project. You can also see on GitHub all the statistics, so you see that the average somewhere around 100 something commits per month. And all that I talked about so far was just the main repository. The main repository is basically the glue code that is putting everything together. It also contains a lot of so-called extensions that are pluggable pieces of functionalities that you can include in your applications. These extensions which are in this main repository are referenced as core extensions, but because the main Quarkus repository is already 1,342 modules, so a lot of modules, which takes a lot of resources to compile on these kind of machines. They actually, if I run, I think I tested it with more than 6 threads in parallel, like Quarkus build, I will basically freeze my computer and I need to restart. Because yes, this is a really bad machine, but also it's a lot of stuff to compile. So some time ago, like 5 years ago, we made the decision that we will no longer accept any extension to come into the main core repository. We created this organization called Quarkiverse, Quarkus Universe, which basically only hosts Quarkus extensions. So yeah, I cannot click this. Oh, that's nice. I need to do this like this. I didn't make it a link. Sorry. So I will make it a link now. So this Quarkiverse is really just a bunch of Quarkus extensions. This is nothing like so fancy. Quarkus extension, again, is just basically a glue code that is integrating any library, any kind of code into Quarkus. So basically you will get access to Quarkus APIs, which I will be talking about later. And basically the user knows that if they are using the extension, they can have some expectations on top of what the library does. So basically now, if you will count that I have this awesome library that I want to integrate with Quarkus, we will not give you basically access to our core repository. What you will get is actually a new repository in this Quarkiverse organization. You will get the full access rights to this repository only, so not to everything, only to this repository. And we will set up GitHub actions that will basically automatically give you build, testing, actual releases too, and scraping from the main repository. So basically when Quarkus releases like 337, we can go actually and scrape all the latest releases of these Quarkiverse repositories and create so-called universe bomb, where basically if the user uses this universe bomb, they will have access to the latest Quarkus extensions that you released. So pretty easy. This is really just because it's better for us to maintain it like this. So going back to slides. Yeah, and there is like over 200 of this already. Altogether, we are almost, I think, like almost 1,000 extensions, something like 980. So right now, I can check actually later, but like it doesn't matter that much. So where stands Spring Boot? Of course, a little bit somewhere else. Spring is now how 2013, I believe. So 13, 14 years old. 80,000 stars, 40,000 forks, way more popular project, but what was interesting to me, only 350 releases, which was surprising to me, personally. Of course, the commit frequency is quite similar. I would say that it also averages somewhere between 100 and 150, just they have like extreme spikes somewhere. I suppose this was Spring Boot for. And yeah, if you check the actual release of text, it's like a little bit more spaced, which can be beneficial, but of course it depends what your use case is. But this is interesting that in these 13 years, they are at 1,254 contributors, so we are missing like 50 people to get where Spring is in like twice the time that Quarkus is released. Okay, so that would be for statistics. Again, I don't really want to make this as a, like Quarkus is the best sales pitch. I suppose that most of you are developers or engineers, so you want to see some code. So I will try to like match this, but it's hard for me to talk just plainly about Quarkus is awesome, not showing like any Spring, so like I wanted to show everything. So what the developer experience in Quarkus is, or what it is encompassed in, is dev mode or developer mode. If you never heard about this, this is basically continuous REPL, read, evaluation, print loop of your application in compiled languages like Java, Kotlin, Groovy, Scala, etc. So it's like real JVM, like real compiled language, but you have the same benefits as you would be writing JavaScript or like any scripted language or interpreted language. So you will get this REPL, but like it doesn't stop there. You will get a bunch of features on top of this REPL that are extremely helpful in everyday development. I will try to show you all of this, so I will not really go through them like in like detail right now. Let me actually try to show you this. Okay, so before we will get to pet, oh yeah, maybe I should have started with Pet Clinic. Yeah, of course I started slides and I forgot. So slight change of plan. I will park the dev mode for a little bit because I want to show you. Go ahead. Yeah, don't worry. Don't worry. Don't worry. I know that I need to do this. Okay, so I want to actually show you something which I am doing right now, which is actually means right now, like it's really like right now. Which is integration of so-called Quarkus migrate command, because if you don't know, like Quarkus ships this command line binary, which you can use to operate on top of Quarkus, and I will be using it a lot when I will be talking. But we have a bunch of commands which can actually work outside of like directories or in like some like general manner. One of these is this update command, which I will be showing you later, which is using open rewrite in the background to update basically Quarkus version automatically in the background. I will show you because for sure the AI will generate something which is not going to be the latest Quarkus. So I wanted to create something like Quarkus migrate. So for that reason, I have this like very special alias that is pointing to really, you see, Quarkus CLI snapshot. But hopefully this will be one day released. And with this CLI dev, I now have migrate command help, which, because the higher ups made the decision that we are going to first do the automated migration from Spring Boot based on LLM models, is actually automated AI migration that is done transparently for you in the background. It is using something which is called ACP protocol. For those of you who doesn't know this, it's agent client protocol, something similar that basically MCP is, but this is intended for basically abstraction of the client and agent communication. Basically, the company that came up with this was JetBrains, that is doing IntelliJ products, because they wanted to basically abstract APIs like Claude, OpenCode, Pi, ACP, what was the last one? Gemini has something also. So basically, they want to have one protocol that they can integrate IDE with and abstract basically the company to which, or the model to which you are talking. What we did is that we wrote the command line client that is encompassing this. So what I can do now is basically start a conversation, which for me it will be conversation with the code in the background and actually automate the communication with the agent for you, so you don't really need to touch it. So there is a bunch of stuff that you will be able to set here, but the only important one, because by default there are what we will do is basically we will tell agent to pull a skill that we are developing on Quarkus skills. Yeah. So we have this repository Quarkus IO/skills where we are actually now maintaining only two skills. One is migrating Spring to Quarkus, one is Quarkus update. So basically what the agent does is it will basically take this skill, run it against your project, and if it's successful, then it will run that update skill, so you will get to the latest Quarkus. But by default, you have some choices that you can make here, because this is how it was designed. And one of these choices is a strategy, because in Quarkus we have this Spring compatibility layer. So so basically we have a bunch of extensions which are prefixed Quarkus-Spring-something, and what these extensions do is basically they will take Spring APIs and they will plug Quarkus stack underneath. So basically, in theory, and for like simpler application, it works like 100%. You can just change the POM XML or build Gradle to use this Quarkus Spring Web, Quarkus Spring Data, JPA, etc. And you don't need to change your code, and basically you will switch to Quarkus. Of course, there is no intention to basically ship this to production. It's just the intent is to make the transition easier for starters. So if you don't want to migrate the code, you can start with this to at least see a little bit of benefits that Quarkus will give you, because of course if you will then rewrite the code to use the stack directly and not do these translations, it will be way more performant. But like even with this you will get like really nice numbers that you can start comparing. So this is actually what I chose by default in that skill because it's faster. That's the only reason, and of course the less you are talking to agent, it's also cheaper. But for this, what we are going to do here, I want to do like a full Quarkus migration, so I will pass this flag Quarkus full. What this will do in the background, it will start, so basically it will check which of the local client basically implementations you have on your computer. So I have two, so I can make a choice. If you don't have any, it will basically give you an error message that will tell you what you need to do to install them. And this is already starting a connection to my local cloud instance, and this is already talking to my local cloud agent, so it's starting migration. But of course, this will take like 15 to 20, maybe 30 minutes. So I wanted to run this in the beginning, but I forgot. So now I can keep it running, and we can do something else on different terminal. But I will do it here. So now
move. So again, what the command does is it migrates the whole project, rewrites it from Spring to Quarkus.
Yes, and I ran it now in Pet Clinic. This is like really cloned main of Pet Clinic, so we will see how far it can get. But like spoiler alert, this will probably not be like full migration because the context window that I have for code is quite small. But we have like successfully migrated it. It's not that hard, like even with the effing time leaf templates, which take forever. But in the end, I will show you like the full migration that you can check yourself. Okay, so you see that basically what it does, it will pull the skill, it will execute the full migration workflow, and blah, 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 blah. It's already doing whatever it needs to do. So we will get back to it later. So going back to the dev mode. So say the junk. This Quarkus CLI is actually like able to do a lot of stuff. One of these is create applications that like even when you are running like commands like update or you will do migrate, in the background it's not magic, it's just calling either Maven Quarkus plugin or Gradle Quarkus plugin. Basically this CLI will just shield you from the actual build tool that you are using in the background. But if I type like Quarkus dev that I will be using in the project, it's the same thing as I would do Maven Quarkus dev, which is normal Go on top of Quarkus Maven plugin. But this Quarkus create is not so fancy. This is actually running just a normal, basically not curl, but like some HTTP client to call that Quarkus.io, so which is the exactly same code.quarkus.io, which is exactly the same as start.spring.io, where you will basically click configure your application and you can see like how many extensions you have, which is extremely long list, so you can actually see it's a lot. You will trust me. But I prefer to use this terminal. This is also possible to do directly with Maven, not with Gradle, because Maven can actually run without a whole project setup. Gradle can't. So, but like for now, this is like the easiest, very easy to install. So if I want to create an application, I will do io_xdevfunc, and let's do whatever, bjug, whatever. Maybe I can create app. And it did work in the first time, even if the command was wrong. Oh yeah, I'm surprised. mrf bjug. Let's do it correctly without errors. Thank you. So, now this one. So, if I open this in IDEA, this is nothing fancy, don't worry, I know I need to make it bigger. Nothing fancy, just a single endpoint that is returning REST and some tests for it. By default, it will pull latest Quarkus, so it's already on 337. Now, if I want to run this, of course I can compile, it will give me a runnable jar. It's not fully a fed jar, I will show you later, but something which you can run. But something which Spring doesn't have is this dev mode, which I can run with Quarkus dev. So this will actually compile and run my application in the background, but you see that it's nothing else than Maven invocation in the background, so I am not lying. And this is already running my application in something which is called dev activated, live coding activated. In the end, the last message is showing you which extensions you have installed, so this is like some very sensible default. But this is already running my application, so if I call it on 8080 hello, I will get back hello from REST. So that live reload, because I suppose that's not something that will be interesting to people, just means that if you, where is it? If you change the code and by default on HTTP request, like this, or if you press S inside this terminal, or if you change a bunch of different files that will trigger automatic reload, but these are the two most common ways, you can actually, for quite some time, also set this to any random file on your file system, because there was a use case for me for this, so there is a flag that you can set up to any kind of file that you want to basically delete. If you change it, it will trigger the live reload, and you see that the changes are directly applied. This magic is actually possible because we are using something around 50 class holders, which we are trying to get to a lower number, but so far no really luck in this. But we are actually keeping several versions of the applications in different class holders. So when you are changing your code, we are basically recompiling dynamically in the background, and when you will hit it with HTTP or force the restart, we will switch the basically class holder that is handling the next request that is going to be handled. And this is continuously switching. This is not so interesting, but this terminal is also interactive. You can see, hopefully down here, that I can press some buttons and magic happens. So if I press H, I can see actually all the commands that I can run in this directory, like that forcing of restart. But I want to always show this instrumentation-based reload that I can trigger with I, which I will not do before I will do some change, which is particularly useful that if you do, that's the private, let's do correct, private atomic long counter, and we will be counting our invocations. So again, sorry, I'm just used to always have it on this workspace. You know what, let me actually do magic. I will take agent and I will move agent here because I will be making this mistake a lot. So hopefully this is now correct. Okay. So if I now reload the application, I should get now my counter going. Oops. Come on. Live demos. Come on. So I have my counter. If I now make any change to the application, like let's say that it's 2027, of course, when we will restart the full application, we will lose the state, which is expected because you are restarting the full application. But if I trigger that live reload, so instrumentation-based reload is enabled. So now if I say that I am on 5 and I will change something within the method boundary, boom, the state is actually preserved. And you will see that live reload was performed via instrumentation, no restart needed. So what this does is actually, if you stay within the method boundary, so if I do whatever, help me AI, hello world, if I stay within the method boundary, I can actually do a slide hack, and that is that in bytecode we can actually see where the method starts and when the method ends, and we can directly plug the piece of bytecode from the running class loader and plug a new piece of bytecode into that same place. So if you will stay within the method boundary, you can actually preserve this state. So if I do this, you see that the state is preserved. If I change anything outside of the method boundary, this is no longer possible, and you will see that the full reload will take place and the state is lost. But as long as you are within the method, this will work. Why is it not enabled by default is because basically, of course, this is quite dangerous because you are touching directly the running JVM bytecode, already compiled bytecode. So it, of course, can blow up, but in my testing, I never was able to blow this up. So I am actually using this by default in my testing. So that would be instrumentation-based reload. Moving on. The next big feature that we have actually on the top is continuous testing. So I can press R to resume testing, which I haven't started, but it doesn't matter. So if I press R, you will see that at the bottom, Quarkus will actually run my test, which is the only test that I have currently in this application. It is here, which is testing that whole endpoint that is returning this particular stuff, which is of course not doing. I will, for the sake of my sanity, just really quickly change this because otherwise I would need to do a little bit more comprehensive testing, which I don't want to do. If I now just save that file, Quarkus automatically rerun the test, and you will not trust me that it automatically rerun because you don't see it. Let me do this. So if I return the test and just save the file, you will see that it automatically reruns that single test, and now it's failing. I can actually press O here to see the actual test output of that application, but now I need to restart it because I didn't do any changes, so you can see actually the whole run of the application. By default, a dev mode runs on port 8080, and the test always runs on 8081, but of course it is configurable. So actually your dev mode application will not conflict with whatever the test is testing. That's the point. But if I now fix the test and save the file, Quarkus automatically restarts the test, everything is passing now. So this is continuous testing in a nutshell. As you are changing your code, and of course this is not only for test, if I change the actual code of my application, it will rerun the test again, and I can see directly, usually I have this on the second monitor, and I can directly see that I broke something and I need to go fix it. One question that is always present for this is that if it will run all the tests, it will not. We actually do have some logic in this, so we are actually trying to detect which tests are actually testing the code which you just change in this particular iteration, and it will not run everything. So I don't know if I want to waste time on this because I already have time out, which sucks, but we can be here until 10, so it's okay. I can show you this, but I don't really think that is necessary. So we will trust it that if I would just copy paste this greeting resource and test /hello2, if I copy paste the test tool, which is testing that /hello2, if I just change one of the resources, it will just run one of these tests because it can detect that one test is testing one endpoint, second test is testing second endpoint. I can do it, but like I don't really want to waste time on it. It's not that important. Okay, so of course. This is not, come on, how did I fix it? I forget always. This is not problem of Quarkus, this is problem of my terminal, which is Kitty, but I will be able to fix it. I know always that there is a trick, but I forget what it is. So, you can also toggle log levels, which is not that interesting. You probably know this also from Spring. You can actually run some terminal modes, so you can actually add any custom command on top of this if you want, but it's not that important. For that continuous testing, I will be not showing this, but you can trigger different modes for different stuff. One trick which I can show you is that actually you will see that when I'm now rerunning the test, it runs in like 250, 300 milliseconds, something like this, you see. What I can do, because similarly as in Spring, Quarkus test is denoting basically start a new Quarkus application on that port 8081 and run the test against it. If I just comment this out, now it's normal JUnit unit test, which will basically call automatically, because this rest assured, if you are not familiar with this is the rest assured library, is automatically configured with this Quarkus test to point to that 8081, to that newly started testing application. But if there is no Quarkus test, this by default points by a chance to 8080. So if I now run the test, you will see that it takes like 20-30 milliseconds. Why is that? It's because now I am not actually starting a new application on 8081. I am now actually calling the dev mode application directly. So if you have a lot of tests, this is extremely easy, and definitely if you have tests which are cleaning after itself, this is extremely useful because this will basically reuse the same application that you are testing on for the test, for that continuous testing. Oh, okay, I will return it back and we can continue. That is the terminal. So, that will be continuous testing. Exceptions I can skip. What I can do here is actually also W and D. So if I press W, you don't see it because this projector sucks, but there is like number one workspace that opened, which is default HTML, which is generated, which is not that important, but this dev UI is. But I want to actually open it from the terminal. So if I press D, the same thing happens because it detects that I'm using Chrome, and it will open this. You will not see it, but it's localhost 8080/q/dev/UI page, which is automatically started only in dev mode. So dev UI stands for developer UI, like UI into the dev mode. What it gives you is basically visual representation of the terminal application. If you prefer to click, this is where you need to go. You can see all the extensions which you currently have in your application, and each of these extensions, I'm not sure why my computer is so slow, but it doesn't matter. it's basically able to do any kind of information that they want on top of this page. So if I have, for instance, my REST, which is our REST stack, I can check all the endpoints which I have here. If I click it, I can call it. I can see like some exception mappers, cores, etc. For instance, this is Arc, which is our dependency injection framework, which is actually built-time dependency injection framework, into which I want to get by the end. But because it is built time, we can actually check like which classes are actually not injected anywhere in the application. And even in this really basic hello world, where I have basically 0 user-produced bean, well, only the REST resource, you see that I have 71 classes which are not injected anywhere or are injected only for the stuff that we can actually process during build time. So these 70 classes will never make it to the final jar that you will be shipping to production. I will get to this later because like I want to cover a lot of stuff, so it's like impossible to go into much detail, but we can talk later. You can also see all the configuration properties. So you see that I have 1,500 properties in the hello world. If I search for something, I can find it here. If I change it here and click save, you will see that it was saved. Dev mode automatically restarted. The configuration took effect. And if I go into my application properties, you will see that it was actually written into application properties. So it's not that you need to go and hunt like what kind of property I need to do. You have all the properties which are currently available inside this application all in this page. So if you add extensions, new properties will be added here. Of course, if you remove them, they will be skipped. Nothing that fancy. What you can see here is this like lock symbol next to some of them and not through all of them. This lock symbol means that the property is only applicable at build time because we are doing a lot of stuff at build time, and build time, if I didn't say it, is Maven package or Gradle build. So basically, if you have this lock and you will try to set this path when you are running java -jar, we will basically tell you, sorry, this has no effect because this was already baked into that final produce binary or jar or whatever you are running, and you will be not able to override it anymore. You need to actually rebuild that final artifact. You have also the view of all the files, so if you don't have IDE, you can actually do this here too. Endpoints are not that interesting. You have also that continuous testing, so if you want to click to run the test, you can do it here. Dev services I will show you a little bit later. And yeah, you can also see a very nice graph of all your dependencies. It's not that interested. And this is the default page, which is not so interesting. Okay, so that would be more or less the UI, but like the really important stuff is that if I now I'm actually here. I can list all the extensions that are installable inside this particular application with Quarkus extension minus installable, which was short version for what I wrote. So I see all of them that are installable in this application because I have like 2. So it's basically just like what I want to show you is that somewhere here is that I can run Quarkus extension add to add an extension. So if I do Quarkus extension add small-rai open API, which is just our open API library, which of course I don't have installed because there was a release of 3.37 yesterday. So you see that dev mode can also survive that I don't have like the jar locally on my machine. So it will download it and still lives. And we should see small-rai open API here. So if I go now back to, which was of course automatically reloaded. Of course, I didn't know that we had this. This wasn't here last time that I did this. So I see the small-rai open API. You see that I have now like Swagger if I want to share a bunch of stuff. And if I go into the configuration and search for Swagger, for instance, this is how you type Swagger, yes. So I have some Swagger. If I remove the extension, they will not be here. And actually, we should see this in the number that now I have 1,600 properties because that extension added 160 properties, which is interesting. So that would be more or less the dev UI. And moving on to the last thing that I want to actually show because it's interesting, is that dev services for which we have tab there. So let's say, I think that I have it in slides too. Yeah, I have it in slides. I will do the slideshow. So what I showed you was continuous testing. Compilation failures, I did not, but like if you do compilation failure, boom, boom, come on, idea. What the fuck? Sorry, YouTube. What happened? I cannot type on my computer. Huh? Here I can. So it's only idea. Now I can. Okay. So now if I try to restart the application, of course, if I would restart it in any other manner, my code doesn't compile. That mode can still survive it. It will just tell me that I need to fix my code. If I fix it, we are back in business. Everything runs. So compilation failures. Go ahead.
And it's do all the time this real world state?
Yes.
Oh, okay.
Oh.
And it's not like overdo like one actor?
No, like I used to run this for weeks and I had no issues.
Okay.
Like really, the compiling of Quarkus itself is more resource demanding than mode. Definitely, the bigger the application is, the more stuff will happen. But we are also don't need to recompile everything because we can actually see the changes between each iteration, and if like each Java class compiles to its individual bytecode class, so the class loader can just really reload the classes which had changed. So it's like really working pretty nicely. It doesn't need to reload like the whole application. And in the worst case, you can still use that instrumentation-based reload because most of the time you are just inside the method. Very like bigger chunk of the work is done in the logic within the method, not in changing all of the like stuff and the like basically bootstrapping of the application. So inside the method, that live instrumentation is really just plug and play. So I showed you compilation failures, dev UI config I showed you, interactive terminal I showed. So dev services will be next, but I will have it on the other side. You have also integrated error pages, but it's not so great. Import script for most of the stuff that has some like client UI, there is an integration directly into the UIs of GraphQL, gRPC, Mogmailer, etc. And of course AI, because we actually are maintaining within Quarkus, but it's of course like a separate project called LangChain4j, which is very popular, I hope. Java AI client library, and this has its own set of extensions which also give you like a really nice stuff directly in the dev UI. So for instance, any agent that you will configure to be automated within your code is also directly available for like direct communication in the dev UI. So basically you can test the prompt before you will basically bake it into the application. So, and dev services. One of the best features in my opinion. So what I will be showing you, but imagine it also like for a slide. Imagine that you want to write an application that wants to connect to Postgres. So what you will add is an extension to connect to Postgres, which is JDBC Postgres SQL in Quarkus. And this extension will be checking for one particular property to actually check where your Postgres is running. So if you will, basically this is the property, Quarkus data source JDBC URL. So if you will not set this property anywhere in your configuration, if you will, then basically we will respect it and we will connect to wherever you will configure or point this property to. But if you will not, then we will basically go ahead and install a dev service, Postgres, which means basically start Postgres SQL container, and we will inject this configuration into your dev mode application, and this works in dev mode and in test mode separately. Okay. So let me show you this in practice. So if I do Quarkus extension add, no, come on, extension add JDBC. Okay, I need to type it because I don't have it. Okay, extend. Okay, let me do magic because I don't want to. JDBC. So, okay, thank you. So, Quarkus extension, the JDBC Postgres, and something which we call Hibernate or RMPana, which I will show you, hopefully. Hopefully you don't mind that I will take a little bit more than 1 hour. Go grab a beer, because I want to talk about this a little bit more. This is the benefit of JAX. So you see, I just edit the JDBC driver, And I didn't configure anything. So in my configuration, I still have only that one single log console darken. So what Quarkus did, you can actually see it already here. Setting, blah, 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 that's not that important, but started container ID, blah, 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 for dev services for default as a source. So what it did do is actually inside my help, but my H doesn't work. I now have dev services here. And you see that I can press C to show dev services container. So I will press C. And you will see my single dev service, which was automatically started, JDBC Postgres container, where it is running, how to connect to it, and the injected configuration Quarkus data source JDBC URL pointing to localhost 32892, which if I do docker ps here, you will see that it's exactly the same container, which is somewhere here, and is running on 32892. So this is the magic of the services. Now my dev mode is really connected to a real Postgres database running in container, which is managed by Quarkus in the background. Go ahead.
Is the schema created based on the entity object?
Yes, because of that message, which was somewhere here, that we are setting basically drop and create the whole schema. It will be by default using Hibernate generation strategy, drop and create, so it will basically do ORM directly in the background. And I can actually show you this.
What if I want to apply some change sets like liquid base or something?
So there is a separate liquid base extension, so you can, but for like this plain JDBC connection, you can actually do file here import SQL, where you will type whatever SQL that you want to do, and this will be rerun automatically every time that you will restart the default. So if you want to create a drop schema, you can do it here. But I will not be doing that because that's a little bit more advanced use case. So if I create an entity, let's say talk, most of you are using JPA, Spring Data JPA, or somebody is also using JDBC or something more advanced, JOC, something like this. Most of you JPA? Okay. So you know what you need to do when you want to write a JPA entity, because you are using JPA, so you know that it needs to have this entity annotation, that you will do a bunch of, well, of course, ID, which I will not. You need to do private fields, getter setters. What else? Equals hash code is mandatory, I suppose. I don't remember. So you need to do a bunch of stuff. Typically, this entity is quite big class. What you can do with Quarkus is actually write public fields, because that's not something that we want to do if we have a private field and public getter setter, which is just getting and setting, right? Which is exactly the same thing. So let's do string title, yes, public, string description. This doesn't matter. It's not that important. And with that panache, which is our custom project, which is actually done by the same Hibernate team that is doing Spring Data JPA, because you are using Hibernate behind it. Basically, the idea was that Hibernate team themselves wanted to create a very simplified version of whole persistence layer. They call it panache, which I forgot what it is, but the basic point is that it's extremely simplified JPA, or extremely simplified persistence. So all I need to do is extend panache entity here. You will see that it's from that panache package, and this is my entity. This is everything that I need to do. And you will not trust me, but you will trust me because you have to. So I will do just really something that we, come on, so have something to test. Account talks. And this will be list of talks. What this panache is, by extending that panache entity, you will get a bunch of stuff. For instance, that ID. If you want a custom ID, you can extend actually panache entity base, which is actually here. So you see that, oops, come on. Panache entity is just extending panache entity base and adding some default strategy for ID, so it's nothing that fancy. And that panache entity base is implementing something which we call active record pattern. So usually in Spring you are using repositories. This is also possible to do with Panache, but I actually prefer this active record pattern because with repository you always have your entity and you have a separate class or interface which is your repository. And repository is basically handling the operations for the entity. In active record pattern, this is all encapsulated into a single class, into the entity class. So active record pattern. So if I now want to basically return, what happened here? If I want to return select star from talks, all I need to do is return talk, static method, list all. And magic happens. If you would like to, there is actually like really directly in this extension, there is already an option to do a repository. You will just need to create a CDI bin, which is extending Panache repository something. And you will basically have repository that list all the same thing. So it's basically the same operations. Now they are just included directly inside the record. And if you have repository, they will be extracted into the repository. This is how you will use a static method. But if you will do something like post, but let's do also talks, public talk. And I would like to persist the talk which I receive here. All I need to do, AI is wrong. I need to actually take the object and call persist on it. I need one more thing because this is a relational database, so I need to put it into a transaction. But you see that you basically with that active record, you will either get instance method for stuff which are operating on a single instance, and there is a bunch of them, or you have a bunch of these static methods which are operating on top of the whole table, so all entities. There is like this list all, there is count, there is like find by something, like some defaults, everything is like doable, and you can still write the full, well, now I'm not sure if it's like JPQL, but for sure at least like Hibernate query language, but essentially you can write the full select statement in this, but you don't have to. So if I want to like find by, let's say, title, I can do it like this, like whatever. You get the idea. Go ahead.
Does the post method need to be transactional if we are working with a transient entity?
It needs to be transactional if I want to actually commit this into a database, and this is not because of the post, this is because of that persist. Because that entity, as you correctly say, is not actually managed by the persistent context, so that's why I need to put it into transaction. Here I don't need transaction because this is just a select into a database. But this would not run because we can actually detect that you are not committing the transaction without transactional.
So the commit is not made outside of the transactional?
So yes. So this is really because I'm using relational database. If I would use something like Mongo, I don't need transactional at all.
Is that also Spring behavior? I think like
I am not sure if Spring is doing this automatically, but definitely it will fail at the DB. Because if you don't have a transaction and you will try to like update a row, it will probably fail. If you are not using something really dangerous, like read uncommitted, I think, which I don't really think that it's even possible to do in Postgres. I believe that like Postgres should fail for you if you just run like single update and you will not commit it. Nobody will see it, like ever.
Like I don't work with such small applications that I would have opportunity to try this out. But yeah.
I can actually like, if we will have time, like, but after the talk, because it doesn't need to be on YouTube, but just out of curiosity, we can try it. But if I will remove this transactional, I can tell you that Quarkus will fail, that there is no transaction, and I'm just trying to do persist into a database. Okay, so now if I basically rerun the application, of course, missing return statement. Again, I don't compile, I don't mind. Now I do compile, I don't. What? Persist? Oh, persist is not returning. So at least you see that it's very hard to kill this, even if you are stupid and you forget a lot of stuff. So now if I would remember how to do PSQL to do select, because I don't, you would actually see this. If I would connect to that container, I would actually see that the schema is now created. And if I now do hello talks, I will get nothing because there is nothing in the DB. Let's try to do post on 8080/hello/talks, and I did title. What is the title? Quarkus versus Spring, and description. Very nice. Oh, unsupported media type, and something which I also have here. I have octet stream. So I want to actually use JSON, as you can see. All I need to do, Quarkus extension at rest JSON. Magic happens, of course. Live demos, I killed the dev mode, which is hard to do, but possible for sure, but I can just restart. Usually it happens in a time when you are trying to actually change something and it's adding some like background magic which is not yet imported, but it doesn't matter. You see that now I will get a new container started if it runs. So now if I do post, it's bad request. Come on, what did I do wrong?
Closing bracket.
Thank you. Live demo. Okay, now it's not there, and HTTP hello talks. I'm getting back stuff from a database. If I would connect to a database, this is really now in the container. Nothing that fancy. But you see that how easy it is to write something like this. So now, before we will return back to slides, I want to just really quickly compile this without test. This is just my magic. Quickly check. Oh, migration complete. We will see what happens there. But I will show you very soon, like what I want to actually show you. So you see a bunch of magic. This dev services stack for a bunch of stuff. We have like 30 of them already working. Still, if somebody has an idea of something else, it's extremely easy to add. And this is always encompassed within that extension. So if you don't have the extension, nothing will be started. Everything you can disable also with the configuration, if not only with the configuration of the direct property like that database URL, there is also like direct property to disable all the dev services or any particular dev service. There is also a bunch of them in Quarkus, but there is probably more, but I was too lazy to check like 200 repositories. You can also plug any custom Docker compose into this. So if you have the whole stack that is for your particular stuff, because of course, like the images, like the Postgres image is configurable also within the dev service, but if you don't want to do the stuff that we provide out of the box, you can plug your own. And that would be more or less everything about that vault. So, yeah, I will go a little bit over 1 hour, a little bit. So, performance. This is the stuff that I want to mainly talk about because this is where we can do actually better, way better than Spring, but not so, as we will see. So these are the actual statistics that we have currently on Quarkus.io, but take them with a little bit of grain of salt. For those of you who are not familiar with any of the stuff written on this slide, just shout, but like very shortly, the important numbers is OpenJDK, transactions per second, Quarkus, and Spring for the same application, which you will see in a minute, and startup time, or like time to the first response. So it's not the number that Spring Boot or Quarkus prints when it starts. This is actually the first HTTP response that you will get from the application. And the same stuff for Gravia native. So that's the native binaries that I mentioned here and there. It's basically a project from Oracle that is able to compile your Java application into really binaries, 0, 1s, which are tied to a particular platform on which it is built, but it then starts extremely fast, you see, and you will get reasonable performance, but I will get to that later. In terms of memory, here we are using resident set sites, which is actual memory that is occupied inside RAM, or VRAM of your application. So you see that after first request, Quarkus is doing something like half of Spring Boot. For native, it's even a little bit more. And now, why this is happening? Again, that numbers, take them with a little grain of salt. They will be changed a little bit, and I will be talking about it at the end. But I want to explain the concepts so you understand why the performance is better in Quarkus, not like the actual like particular numbers. So this is your typical Spring Boot application. When you finish developing, you will do make on package, create a build. All you will get is jar, uber jar, fetch jar, java minus jar, that you can run. When you will do the java minus jar, a bunch of stuff happens every time that you will run. You need to basically load all the configuration and Java classes or Kotlin classes or whatever. You need to basically load everything into memory and parse it, of course. Then you need to check all that stuff that you loaded for annotations, in particular auto configuration in Spring. You need to generate a bunch of stuff, enable, disable stuff, etc. It's a lot of like find and basically do something. After that, you will build the representation of the whole application. This is where dependency injection usually happens, magic. So you will wire all of the generated stuff together, and only then you can actually start the ports, thread pools, etc. to actually start your application, and then your application runs. What is important is that all of this happens every time that you will do Java minus Jar. Where Quarkus did a slightly better design choice, and why we basically did Quarkus is that we basically created a framework that can split this into two phases, build time and run time. Build time, really the main package or Gradle build will do as much of that processing that Spring does on every application run, only once when you are building the application, package the results into that final jar or GraalVM image that you will create, and then when you will run the application, it will start way faster, it will be way smaller, because all the stuff that you basically use only here doesn't need to end in that final jar. So imagine that you have persistence XML, which is still very popular, unfortunately, which is usually the only XML file that is in your application. It's still an XML file, so for that you need an XML parser. So it's actually, there is a class in Spring that lives inside your jar, which was only used once every time you start your application to parse that one XML file. And it, like, even if it's like the object of the parser is garbage collected, the definition of the class lives there till you will kill basically the JVM. And there is a bunch of this stuff, basically, that you don't really see in the background. In Quarkus, if we will read that XML only at build time, we will never include that parser in the final jar. So you don't need to instantiate it, you don't need to have it taking some memory, which is like, of course, small number probably, but it is something, and this adds up. This is the performance numbers that you see there. This is why it is faster, why it starts faster, and why it basically can do more stuff. Yeah, more or less, this is everything. This is why we actually make these distinctions for build time and run time, because like that configuration, for instance, once it is baked inside that jar or GraalVM, you cannot change it anymore, because you need to basically recompile the application. But this is extremely small price to pay, because usually you don't really care if your main package takes like, let's say 2 minutes or 2.5 minutes, because nobody really checks that. And much of this stuff you never need to really touch inside that final jar. And if you do, this is like really a choice. So if you will make a compelling case that this particular build time property I need to override in every time that I run my application, for us it's just moving it from one place to another. Yeah, it's probably not. One last thing. Because we are doing this as main package, we can actually do a lot of magic here in build time and actually change and transform your code, generate a bunch of code. For instance, that arc is a build time dependency injection, so it can actually do all the dependency wiring at build time. So if we see that something is not injected correctly, or you somehow mismatch types, etc., we will not compile, which most likely Spring will compile, and you will find out only when you run Java minus Jar. So, that numbers that I showed you are actually fully available on GitHub, and you have this, come on, this is also not clickable. Okay, I will do it like this. You can find this on GitHub on Spring Quarkus Perf Comparison, which is free repository for anyone to touch. So we have Quarkus free, Spring Boot 3 and Spring Boot 4 with a bunch of scenarios tested. I'm not sure if we have it here. Yeah, so there is out of the box and there is tuned, which is really tuned for performance. And we actually encourage Spring people to go here and actually make the Spring applications better because we want to see like the best possible numbers. And I don't know if we have it here. Yeah, there is like a bunch of scripts that you can actually use to run this on your computer. We don't have it here. We have it here. So here you can see different scenarios that are being tested. So it's just like a really normal JIT, Java minus jar. We are also using Leiden, Project Leiden, for which we hope that we will have a talk here in September or October. Virtual threads. And yeah, this is also Leiden with virtual threads and native. So these are 5 cases that we are testing. So if you want, you can try and play with it, fix it, but we are having actually a separate, because in IBM we have a separate performance team that has a separate set of machines, which we call perflop. So we are actually running this continuously on our end to basically get the numbers. And you can see this in this repository, Quarkus.io/benchmarks, where you will get the latest and greatest graphs which are not published yet on site. And here I want to point that on site you could see, I don't know where I have the site, but it was like something like close to 19,000, 18,000 something transactions for Quarkus 332. In Quarkus 335, this is the latest graph, we are only on 15,000 transactions per second only. It's still double the Spring Boot, but what happened is, because I was actually asking, it was surprising to me, our main performance guy noticed that we are basically too generous with resources in the perflop, and they basically nerfed the perflop, so this is why there is a lower number here. And this is something which I want to actually show you because it's really interesting. If I will find where I have the presentation. So let me do it like this. Boom, boom. So I picked 3 issues which are actually in that Spring Boot performance repository. This is everything on GitHub, where you can see that we are actually trying to help Spring to get better because we want to get real numbers. So there is like this one, which is extremely interesting, and if you want, I can point you to a blog post, which is actually also here, where we basically noticed that the scenario which we are running is basically warming up for 2 minutes. You can see the Quarkus is it blue? I am partially blind, so this like lightish bluish color and this yellow greenish, whatever, is Spring. You can see that Quarkus will warm up way faster, or will get very close to the peak performance way faster than Spring does, because Spring will get there only after half a minute of cooldown for some reason. And that was something which was extremely interesting to the person doing this benchmark. And what they found out is that basically Spring is doing so much stuff that the C2 compiler is not fast enough, or it doesn't have enough space during the warm-up phase to actually optimize the code. Only in that half of a minute of silence, where we are not pushing new requests, the C2 can catch up and actually optimize Spring code, all of the Spring code, to get to the peak performance. So if you will not give it that breathing time of half a minute, it will never get there. Make your opinions. Very interesting issue, so if you want, you can check this later. You will have the link to the slides, and you have actually that guy wrote a blog post about it, so you can see it. But another interesting one is that we were running this originally, that stuff that you saw on the side, that's 18,000 something transactions per second, was running on a turbo boosted machine, which was running at 3.8 gigahertz, I believe. They nerfed it to 2.5 gigahertz, and that was the hit for 3,000 transactions per second. I will not show you this side by side, but Spring took 100 transactions, so it was 7.6 or 7.5. So we actually estimated that probably Spring is hitting limits somewhere else than Quarkus does. And the guy actually ran this test with only 128 megabytes of heap. And you can see that the performance for unlimited heap was 13.k transactions per second for Quarkus and 7.6 for Spring, which is more or less what we saw on the last slides. But when we throttled the heap size, I really like this. I feel bad about it, but let me show you the numbers first. Spring 4 on JVM dropped from 7.6K to 734 transactions per second. Quarkus from 13.8K to 10.5K. And here you can see the actual benefits of the performance build time optimizations that I was talking about. Because all that baggage that Spring is taking to the actual runtime is like trotting you down in the basically, you have no idea in which ways. We will actually publish this for sure, because what this actually means is that if you want to basically have the same throughput, you need to basically run, like 10 times, so like gigabyte of heap for Spring, and for Quarkus you can just run, like 128 megabytes. Of course, like in real practice, it depends how much are you actually like paying, how big instances in like clouds and etc. you are already paying. I would say that for many people this is not so interesting because you are not limiting your applications to such a smaller heaps. But if we will get eventually into that space, and there is a real possibility that we will, or basically you want to really save the money because you can actually push multiple containers into a single AWS instance, for instance. With Quarkus you can do this, and this is, again, JVM. So this is like really Java still, that is able to do like 10,000 transactions per second on 128 megs of heap, which is amazing, in my opinion.
So when you mentioned before how Quarkus moves a lot of the stuff from the runtime to the build phase, that means that it not only reduces the time to start up, but also changes the throughput. Does these optimizations also help that?
It's like, it was that second part, because like if we process something at build time, we will not include it in that binary. So your application is smaller just because there is a lot of stuff which don't make it into the jar. So you don't need to spend time at optimizing the code which you are not using. You don't need to spend time in like just pulling it into class orders, loading. If there is like a single instance somewhere, like there is a lot of stuff that you need to do. Finding the annotations, like even if you just like do like really like finding a particular annotation, the more classes that you need to iterate over if there is this particular annotation, like the worst case. Like typical REST resource. REST resource is just like add controller or add REST controller or whatever, add path in JAX-RS. There is no like extension of interface or something, so we don't really have an idea which class can be a resource unless we will actually load the bytecode and check, is there a path annotation or is there a controller annotation? And this takes time. This takes resources. And you also, this code, checking for that annotation is still a Java code, so it will still need to go through C1, C2 compilation phases. And this takes time. You see, that guy actually did the Quarkus. We have every week on Monday at 3 p.m. This time we have Quarkus Insights, which is 1 hour talk on Quarkus, any topic, streamed on YouTube, Twitch, something, I don't remember. And that guy that is actually like our main performance person, Francesco Nigro, was doing why performance matters talk, and he basically compared it, which I found really nicely, to a currency. That performance is something like money that you are basically, you either spend on BS, like Spring does, or you can actually save it and you have this budget to actually implement the feature or optimize something else. So if we imagine that if we would basically compare really where Spring is, where Quarkus is, this difference means that I can implement a bunch of new features which are going to fill that space, which Spring doesn't have. Okay, so when you will have this, all of these optimizations, then it's extremely easy to go into native because the native compilation is actually, for those of you who don't know, statically ahead of time compilation of your application. So you will start at some entry point and you will go through all the possible parts of your application because the native is really at the end, 0 and 1s. I don't know how this works in detail because I don't have a dissertation in GraalVM, but it's a very complex process. But basically, it needs to build a world, we call it. So basically, it needs to go to every possible part of your application. There are some possibilities how to optimize this, but we can talk about this after the talk. This is not so important. Yeah, no dynamic, no dynamic stuff, no reflection or resources unless you will explicitly specify it, which basically means that if you have framework like Spring, this is extremely hard because like when Spring Boot was created, there was no GraalVM. They didn't account that this can be an issue in the future, and it's extremely hard for them to now get on the train. But when Quarkus was created, there was a conscious decision that we want to do as little of reflection or no reflection at all because reflection is extremely slow. So if we can actually, instead of at runtime, like set accessible true and call a constructor, at the build time, I can actually create an instance of your class or subclass your class and do the instance like a real instance that in the final jar is a normal object that I can call. It's way faster. And because of this, Quarkus was extremely easy to get on top of GraalVM. Yeah, class path is fixed, that is not all. I actually took this from Spring Boot docs, so here you go. Yeah, there are some limitations, of course, because you cannot do a lot of stuff, but this is important. How Spring does this? So, of course, I don't want to just talk about Quarkus, so I wanted to really quickly show you this actual Spring docs. Now I need to find it because this is like extremely long doc. Where is it? So, in Spring, you are using AOT, ahead of time compilation, which is of course not limited only to Spring, but are any of you actually using GraalVM? Or have you tried Spring Boot with GraalVM? So, you need to use AOT, which by definition will change how you are using Spring Boot because it needs to actually generate a lot of this kind of like proxy stuff to actually not use reflection because this is kind of the point. But what is important, the proxy class generation, I'm already over that. What I wanted to show. Yeah. What it will do, it will generate these hint files, which are basically because the GraalVM is really a binary that you will basically run like native image, something which you can download with GraalVM, which is still a virtual machine. You can actually run Java on top of GraalVM. Many people don't know this. But it ships also this native image tool, which will build this native binary. This native image invocation needs to have all the reflectively accessed classes, all the classes that you will serialize at runtime listed explicitly when you are actually running this native image. So you need to somehow know how to pass this metadata into that invocation. Spring does this with these hint files, which will be living in a bunch of directories. For this, I have actually a link here to that pet clinic because that's like the main application that you are using. So this is really a file, pet clinic runtime hints, which you can find on GitHub. This is really pet clinic, which of course is only the hints which the user explicitly needs to set, like for instance, a register type for serialization. Not so funny to do. Let me tell you this because it's extremely hard to find when you are trying to debug this. And I didn't mention, but native image compilation takes forever. Even for Hello World on my 60 gig computer, it takes more than a minute. And that's just Hello World. The more stuff you have in your application, it will take longer because, again, all the code parts build the whole world. So You see, it's not so easy to do. Of course, Spring does a lot of this for you, but you will need to actually run the application with IoT to generate this in the background, and only then you can actually point it to a native binary. Oh, sorry, too much clicks. And one more thing, because of course this is not only about your code, this is about all the code inside the application, because whole world includes your dependencies and the dependencies of your dependencies. So you need to actually do all of this for all the Java classes on your class path. And I don't remember the last time that I saw a Java application or enterprise Java application without dependencies. So this is what Quarkus does. They actually partnered with Oracle and they created this GraalVM reachability metadata. So you can, for instance, search for Hibernate here. And if I go into Hibernate core, there is this actual data that I was talking about. So how the data that is actually some configuration that they need to pass into GraalVM. So you see that this is like manually maintained by Oracle and Spring in the background. And this is where Quarkus actually shines because of that build time optimizations. Because at build time, I have already the access to basically all of your code that you wrote in your application. I can see which classes are entities, which classes are actually going to be needed access reflectively because whatever reason, which needs to be serialized, etc. And because I know that if you are using my library, this particular subclass will need to do etc, 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 I can actually pass this information to GraalVM on your behalf. So you will most likely never need to touch any of the GraalVM configuration or these parameters, because we, as long as you are using extensions, we will do this for you in the background. So if you want to compile any Quarkus application into native, all you need to do is -d native or -b native, and magic happens. Because every extension is actually responsible to make sure that if that extension is on a class path, all the code using that extension will compile to native. So it's our responsibility. And then, if I will show you that Hibernate example too, I will show you Quarkus code. So we have these like processor classes, which is, wow, this is very nice. And I'm zooming. With these build steps, which is just a method which is executed actually during build time. And you see here that I have defined GPA entities. Somewhere here, I have this discover and model for reflection. And if I go here, I believe, yeah, I have this reflective class, produce, and builder of, okay, enum, it's not that important, but I want to find, yeah, manage classes, for reflection, add, etc. So you see that I am actually scanning dynamically for all the GPA entities, and I will be registering them dynamically for you in the background. That's one magic that I wanted to show, but I wanted to also show you that I compiled that application. So in my target, that one that we had, like the bjack with talks, I now have a bunch of directories. The one that you are interested in is this Quarkus app, where you have your runnable jar, which is by default so-called fast jar. So if you just do java-jar Quarkus run, now it will work. But if you move this somewhere else, you also need to remember to move this lib directory with it, because it is not fed jar by default. It is actually possible to do fed jar if you want to have all the libraries inside that jar, in Quarkus run jar, but you need to basically set a config property for this. By default, we are using this because if you would put this application into a container, all of your dependencies, which are your dependencies but also the whole of Quarkus, can be one layer under that Quarkus run jar. And that means that as long if you don't change the dependencies, you are just changing the code inside your application and you are pushing this image somewhere, then your lib layer is actually cached. And you are just pushing, you know, like usually way smaller subset of your application and not the whole fed jar with all the dependencies. So this is the only reason why this is the default. But like whatever drives your horses. But what is actually important, or what I want to show you, is this generated sources, I believe. No, sorry. I need to find it because I always forget It will be in Quarkus app. It is inside my application. CD app, boom. No. Leave. No. Quarkus. Yes, here. So I have my generated bytecode and transformed bytecode. So that magic that I was talking about. So if I now unzip transfer bytecode jar, what typo? Thank you. I don't see anymore. So if I now open in idea IO xstefan, what was the name of my entity talk.class? So I will decompile now the compiled class inside idea. So this is decompiled class of my entity. And you remember that my entity was just at entity annotation with 2 public fields. You will see that what Quarkus does include in the jar is this. So it is entity with some enhanced info. It's not that important. Extends panel entity, but now it implements also a bunch of different stuff. My public fields have been actually protected now because we can actually transform the bytecode dynamically at build time. So my public fields are now protected. Of course, I will have getters and setters now, but you remember that my actual greeting resource was actually using directly accesses to the, I actually didn't do it. Okay, now I will not show you this. So I need to recompile one more. So let's say that I will just say title equals whatever. And I will see out talk.title or description. So we have something else. I will just really quickly recompile because of course, when I'm doing talk, I will forget what I want to show. This will be really fast. Because I want to actually showcase that when I access the public fields, like directly with public fields, I will actually say the target Quarkus up. Quarkus unzip, and now idea IO Stefan resource, boom. So if I now find where I did actually access that files, you see that Quarkus will actually replace that with the generated setters and getters. And we can do this for a lot of stuff, like this kind of magic. So you can write very simplified code, but in the final jar, you are actually still pushing production-ready code. This is the point. Okay, so, and if I would put this into native, there is the presentation. Of course, it will compile, but I will not spend time now. So, we are getting to the end. Okay, so before conclusions, let's check the actual migration. What did happen? What did happen? You will see that it did actually compile. It did actually compile. Let me do clean compile. Okay, clean compile. I usually need to do this with -d skip test because by default we are actually like telling the agent to do only this command. So you see that whatever it did, it actually compiles. I am almost sure that it will not run. This is Quarkus dev, just alias. I would be very surprised if it would run because the agent usually gives up way sooner. So it does not. But at least we get somewhere. So, of course, this is just a really one prompt that you will hit your agent with, and usually it will. Yeah, there is a bunch of to-dos inside my code, so if I would open this, it will be a bunch of to-dos. But usually you don't really need to do this because what I actually did there is that I found out that if you run out of the context, you can just run this again and reuse basically the partially migrated application to partially fill the context. So it's way easier for the agent to then transform it. And I also added this -- interactive flag. So if I run this again but interactive, and I will use quote again. Of course, it first needs to initiate the communication with the agent. Come on. Okay, while we are waiting on this, one more thing which I didn't know about, but it's extremely useful. I don't have it here. Quarkus agent MCP. I would recommend you, if you are using Claude or anything that is MCP capable, we are actually shipping now Quarkus agent MCP server, which is not intended for you. It contains actually operations for agents like Claude or OpenCode, etc., to actually operate on top of Quarkus. So we will basically give the power to the agent to basically start the dev mode, dynamically check what was restarted, run continuous testing, and this kind of like goodies that I was doing on my computer. But there is also, this is now running. Yeah, so now you see that it's interactive. It will not do stuff automatically, so I need to actually tell the agent what I need to do. So basically I am just like opening a communication with Claude in my case right now, and I can tell it like migrate this in this way, check the communication, etc. One thing that agent MCP will do will also get access to the full documentation of Quarkus, so it's way easier for the agent to do so. And I have it actually inside my Claude, so this is how you can add it to your code. But one thing which I wanted to show you is also, because this is for agent, this is like really, if you really do migrations or something like this that I'm doing, I'm talking to Claude and I'm letting Claude to do its thing. But if you want to do like MCP server for you as a person, I will just start the dev mode again. Come on, Postgres takes forever to start. Damn, only half an hour about that, that's okay. So, somewhere here in settings, you can actually find this dev MCP, and you can get actually for any, I think that this is like all that you can get currently, like commands how to actually add an agent MCP. Oh, basically this is like the same agent. Okay, so I was wrong. I thought that this is a different one, but basically that all the same stuff that I have now currently in my Claude, how to do this for any other like command line agent stuff. So it's extremely easy to set up, and with this, because like it is like definitely not ever going to probably happen, you know, like in one single command that magically you will transfer something as complex, sorry, this is Quarkus, as is Pet Clinic, because that's like unnecessarily complex project, as I found out. Where was it? So you see that now it's basically doing like some other stuff, like no, I don't want to make a PR, so it will basically, now I will have a communication with the agent. So if it tell me that I cannot do something because ABC, I can tell it like, look, here is the documentation, or check the documentation, go search the internet. You have normal Claude communication basically encapsulated in the command. But you can of course run normal Claude, point it to the directory and do your stuff, or any other client. So I will let it run, it doesn't matter that much. But with this, where is the slides? With this, I can finish the slides and we can go for a beer. I believe that my point here was not to convince you that Quarkus is way better than Spring. For sure, if you just look at the real statistics and put them side to side, in 7 years, I still think that we could do better. And it's not like that we are not trying. But Spring is just like extremely popular just because of like Spring Framework before Spring Boot. But I would say that both projects are still alive and kicking, and competition is good for both. I believe that Quarkus moves objectively faster, and we are developing or delivering way more features way faster. However, Spring Boot has a bigger community, and migration will be hopefully extremely simplified very soon, because this is still ongoing work. What you just saw with the tool is again compiled version snapshot from my computer. There is no even PR yet. But one thing which I think that we can all agree on, that there is no other framework that basically took Spring this far, and there is probably no other framework that has the possibility to dethrone Spring one day. And if you don't trust me, we have a bunch of user stories available on our blog where you can see like the real use cases. I purposely didn't touch the API much because I actually believe that we are going to write code very little going on in the following years. So you will have your agents, which you can point to this book, which is really available on Red Hat developers on this link. So there is basically a comparison how you do Spring, how you will do the same stuff in Java EE stack or in Quarkus. And yeah, it works because actually if you have only Claude with that agent MCP skill, and all you will do is basically point it to that migration skill that I am pointing my command line, and you will give it like something between half an hour and 1 hour with automatic accepts. This is actually a migrated pet clinic project where at least this is my director, so if he lies that he ran only this, I don't really think that it's possible, I hope. So you can actually see this in the slides, and if you run it, this will be exactly the same project as pet clinic, migrated with a single command. Okay. Okay, so that would be more or less everything from me, and we can continue playing with the migration and the other stuff. So here you have a link to the slides, and thank you for your attention.